Hello viewers, welcome to my channel Vaira Citadel. I'm Nalini Rajagovindan. We have been discussing topics for UGC-NET paper 1. Already we have seen many videos on research methodology, and today in this video you're going to learn about a very important concept in research, namely hypothesis. You will be learning about what a hypothesis is and how it is important in a research, and what are its functions in a research, and what are the various types of hypotheses, and what's the difference between them. And most importantly, you will learn when to use what type of hypothesis. All this with day-to-day examples from our world of learning. And come on, let's jump into the topic. Now, we will define the term hypothesis. Hypothesis is a guess at the solution to a research problem. It is a proposition about the solution to a problem or about the relationship of two or more variables or about the nature of some phenomenon. It is actually the principal instrument in research. In fact, many experiments are carried out with the deliberate objective of testing a hypothesis. The relationship between a theory and a hypothesis may be illustrated by this figure. A hypothesis is formulated with the first hunch based on theory. The hypothesis is tested by means of conducting an experiment. Observing the results, the hypothesis may be supported or rejected, and more hypotheses are formulated to build a new theory or modify the existing one. Now, we will see the uses or the functions of hypothesis. First of all, it provides clarity to the research process. Because in the hypothesis, we are defining what we are going to do. It increases the objectivity of the research. It provides direction to the research by defining the variables and establishing the relationship between them, whether these variables are equal or not, or which is greater or which is lesser, as in the case of directional hypothesis. Obviously, by providing the direction in which the researcher has to proceed, it helps in avoiding blind research, leading to the wastage of time and energy. And it provides temporary theory or generalization, which on further verification will become a well-established theory. It helps in the replication of the research by providing the direction to the researcher. It helps in drawing logical conclusions. It also helps in operationalizing the procedures by defining the variables and the relationship between them. And it also helps to make probability statements about population parameters. I can give you an example of a hypothesis predicting the population parameter. Say, the mean achievement of population of 8th grade students taught by method A differs from the mean achievement of the population taught by method B. Now here, what does the hypothesis say? It predicts about the population parameters, which is the mean achievement. So, and here this hypothesis is non-directional and it is a statistical hypothesis. We will see in the following slides what they are. Now, we are going to list the important characteristics of an hypothesis, or how a hypothesis should be. A hypothesis should always explain your predictions. That is, it should state the relationship between the variables and it should be done in a straightforward and clear manner. In short, it should explain what it claims to explain. No beating around the bush. And it should be clear and specific. It should not be vague. And it should not have very broad scope. Because a broad scope will make the hypothesis testing unamenable. The scope should be narrow and specific. For example, a hypothesis which goes like this. Intelligent students have good attitude towards teachers. So this is an example of a hypothesis statement. I repeat, intelligent students have good attitude towards teacher. And this statement is very vague and broad because the words intelligent, good, attitude are very broad and undefined generalities. You know that good may mean something to you and good may mean something else to me, and also attitude. You may think of some attitude as good and I may think of some other attitude. So they are very general, very broad. They are not defined here. But now listen, this might be changed to read like this. The new hypothesis says the students aged 8 through 10 in the upper 10% of their class on the standardized IQ test have a higher mean score on the XYZ attitude towards school inventory than students who score in the lower 90% of the class on the IQ test. See, now this may sound very long, but everything is specific here. In this second hypothesis, the intelligent students, what is intelligence is defined as those scoring top 10% in a standardized IQ test. Students are defined as those between 8 and 10. Attitude is defined as measured by a specific inventory called XYZ attitude towards school inventory. Thus, it's more specific and testable form. The student population is also specified here as 8 to 10 years of age and not the entire student population as in the first statement. And coming to the list of the characteristic, the hypothesis should be testable. That means it should be objectively verifiable and testable. It means that there are procedures that will analyze the data collected which will yield results to test the hypothesis. These results will either support the hypothesis or refute the hypothesis. For this, the variables must be operationally defined, meaning that the researcher should explicitly state what tests or inventories were used to measure each variable. The same example we cited now, we can use here for explaining this also. The variables, students, intelligence level, attitude, all these three are operationally defined. We have well defined them. Like what test we are going to use for measuring the attitude and what intelligence mean, that is those students who are in the top 10% of the scores. So, and students also we have operationally defined. Those students who are in the age group of 8 through 10. So, and the hypothesis should also be measurable. Again, citing the same example, we have said that we are going to use XYZ inventory, XYZ attitude towards school inventory for measuring attitude. And finally, the hypothesis should be consistent with the facts or the data we have collected. Now we are going to see about the various types of hypothesis. Broadly speaking, hypotheses are classified into two groups: substantive or research hypothesis. And the other one is statistical hypothesis, the second group. And what is substantive or research hypothesis? They are tentative statements about the expected outcomes for the variables under study. Example for research hypothesis, which is also known as substantive hypothesis. Hands-on workshops increases the performance efficiency of the students in computer applications over a traditional lecture method. I repeat the hypothesis statement. Hands-on workshop increases the performance efficiency of the students in computer applications over a traditional lecture method. This is an example for directional research hypothesis. Why do we say directional research hypothesis? Because we have mentioned the direction, that is the increase in the performance. If we say just a change in the performance, it is non-directional, because it includes non-directional hypothesis. It may include increase or it may result in decrease. So that is non-directional. But directional hypothesis will definitely say whether there is going to be an increase or whether there is going to be a decrease. So since we have mentioned here in our hypothesis that the hands-on workshop experience will increase the performance efficiency of the students, we call this hypothesis as the directional research hypothesis. Now we will see what is the other type of hypothesis, that is statistical hypothesis. And these hypotheses are stated in statistical terms, and they are measures of the population under study. You will be studying about population and sampling. The population is the entire set of people from whom we are going to take out sample and do the research work. So in order to use inferential statistics, which is concerned with our prediction about the population, we need to convert the research hypothesis into a testable form, which is called the null hypothesis, and to generate an alternative hypothesis. Alternative hypothesis indicates the situation corresponding to when the null hypothesis is not true. The alternative hypothesis is a statement that directly contradicts the null hypothesis. For the above example we cited, that is, the performance of the students taught with a hands-on workshop experience increases on the computer applications over the traditional method. So for this, which we said, it was a directional research hypothesis. For this, the null hypothesis would be there exists no significant difference in the performance efficiency of students in computer application between the workshop method and traditional lecture method. So no difference, always null hypothesis. Null means nothing, zero. So null hypothesis always says there is no difference, or no relationship, zero relationship. So that is null hypothesis. And whatever difference we find, it says, the null hypothesis says, it is purely by chance or by sampling error. It is not statistically significant to consider to be true difference. Even if you find little bit of difference, it is not true. It is only due to error, sampling error, or due to chance. The alternative hypothesis for the same null hypothesis would be the performance efficiency of the students taught by these two methods, that is hands-on workshop experience and the traditional lecture method, are not equal. This is one of the alternative hypotheses. The other alternative hypothesis would be what we already stated, that the performance efficiency of students taught by hands-on workshop method increases over the method in a traditional way. What we said, directional research hypothesis. That is also one of the alternative hypotheses. So broadly, the hypotheses are grouped into research or substantive hypothesis, and the other group is statistical hypothesis. Now we will see more about null hypothesis and alternative hypothesis. Now, null hypothesis forms the basis for any research study, and it is denoted by the letter HO. HO means 0, H0. It means null hypothesis, 0, no hypothesis. HO or HN. It is also denoted by the letter HN, N for null. And this signifies that there is no difference between two phenomena. So always null hypothesis tries to establish that whatever difference you see between two phenomena or two variables is purely due to chance or sampling error. Always remember this very important point, always researchers try to disprove the null hypothesis and prove the alternate hypothesis. This is like in any judiciary system. In judiciary system, it is always the accused or the defendant is innocent, which means null. Unless and otherwise it is proved otherwise by the prosecutor. That is, he has to produce some evidence for his guilt. Interestingly, the concept of null hypothesis in statistics is inspired by legal proceedings in a judicial system. Criminal system always works with the presumption of innocence. So what will be the null hypothesis in a criminal case? It would be like this. The defendant is innocent of murder charge. This is H0 or null hypothesis. An alternative hypothesis would be the defendant is guilty of murder charge. And alternative hypothesis is denoted by the letter H1 or HA, A for alternative. So the researcher often creates null hypothesis in the hope of being able to refute the null hypothesis. We will see more examples of null hypothesis and alternative examples. There is no difference between the effects of teaching method A and teaching method B. This is another example for null hypothesis, H0. And a corresponding alternative hypothesis would be the effects of teaching method A is significantly different from the effects of teaching method B. So this is alternative hypothesis, and it is non-directional because it does not say A is greater or B is greater or A is lesser or B is lesser. It just says they are different. So non-directional alternative hypothesis. And one more example for null hypothesis would be the performance of group A is equal to the performance of group B. Again, there is no difference between group A and group B, which is a null hypothesis. And the corresponding alternative hypothesis would be there exists significant difference in the performance of group A and group B. Again, this is non-directional because we don't know whether A is greater or B is greater. They are not equal. That's what we are saying. So this is non-directional alternative hypothesis. And one more example for null hypothesis. The poor performance of students in the test is not due to online mode of teaching. Remember the word not. So it is null hypothesis. And the corresponding alternative hypothesis for this hypothesis would be the poor performance of the students in the test is due to online mode of teaching. I hope this concept of null hypothesis and alternative hypothesis is clear to you, because it's a very important topic and you should be able to tell. I have given some assignment at the end. Please try to do it. Listen to the explanation and grasp the concept and then try to do the assignment. As I have told you, the alternative hypothesis can be of the type directional or non-directional. In directional hypothesis, the alternative hypothesis indicates the direction of the expected outcome of the result, and it shows which is greater and which is lesser. From there, but from where do we get this clue for this direction? The direction is implied by some theories or by the previous research by the researcher or from the literature survey he has done. Example for directional hypothesis, we've already seen some. We'll see one more. The mean performance efficiency of students taught by method A is greater than the students taught by method B. Here, this is an example for directional hypothesis because we know that A is greater than B. And non-directional, on the other hand, in this, the alternative hypothesis does not indicate the direction of the expected result. It does not say whether A is greater or B is greater. It just says that there is difference in the mean performance of students taught by method A and mean performance of students taught by method B. It does not give the direction, whether A is greater or A is lesser, or whether B is greater or B is lesser. It does not give the direction. So it is non-directional. Now, the question arises when to use directional hypothesis and when to use non-directional hypothesis. The answer is simple. If the literature survey already done by the researcher indicates a direction for the result, then a directional hypothesis is used. If there is no convincing evidence in the literature of the direction, or also when an exploratory study is done. Exploratory study is something new. You don't know anything about it. You are going to explore. You don't know the direction. So in that case also, a non-directional hypothesis is called for. Now we have come to your favorite session, namely the assignment session. And for a change, today I'm not going to reveal the answers right now. You mail the answers to me and I'll help you with the correct answer. I hope it's okay with you. Well, that is all about what hypothesis is and why it is paramount in your research and what are the various types of hypothesis. So I'm sure you have understood and enjoyed this video, and we will be discussing about hypothesis testing, the types of error encountered during testing of hypothesis, all in detail in a future video. And don't forget to subscribe to my channel Vaira Citadel and click the bell icon for the further notification. Until then, bye bye.